Here we are given the curve y equals 2x into x plus 1 to be squared, and we are given the point P as 1/8 that lies on the curve. And we are required to find the equation of the normal through point P. Now I've listed the steps here to solve the question, so let's first start by finding the gradient function of the curve dy dx. So y is equal to 2x into x plus 1 to be squared. Now if we expand this out, it will be 2x into x squared plus 2x plus 1, which is equal to 2x cubed plus 4x squared plus 2x. So if we find dy dx, that is equal to 6x squared plus 8x plus 2. So here we've found the gradient function of the curve, which basically gives us the gradient at any point on the curve. Now we need to find the gradient at point P. This simply is done by substituting the value for x into the gradient function, and this gives us the gradient of the tangent at point P. So let's sub x equals 1, as in point P, into dy dx, and we get that dy dx is equal to 6 into 1 squared plus 8 into 1 plus 2, which is equal to 16. So here we found the gradient of the tangent at point P. Now remember that the normal through P is perpendicular to the tangent at P. So therefore the gradient of the normal is equal to minus 1 over the gradient of the tangent, which is 16, because the product of the gradients of perpendicular lines equals minus 1. So now we have the gradient of the normal, and we have a point 1/8 that lies on the normal. So hence we can use the point P and the gradient to find the equation of the normal, as given by this equation: y minus y1 over x minus x1 equals to m, where m is the gradient of the normal and x1, y1 is the point P. So y minus y1, which is 8, over x minus x1, which is 1, is equal to the gradient of the normal, which is equal to minus 1 divided by 16. So this means that y minus 8 times 16 is equal to minus 1 into x minus 1. We simply cross multiply here, and we find that 16y minus 128 is equal to minus x plus 1. Minus 1 by 1 is plus 1. So that leaves us with 16y is equal to minus x plus 129. And this gives us the equation of the normal through P.